Yeah, I appreciate it, Alex. Yeah, it is good morning, so good afternoon to the European folks. So, my name is Britton Lawson. We're going to get into how we talk about a digital contractor and how that applies to Veit. So, I'll give you a quick background. As Alex said, my position is a director of construction technologies at Veit Company. I sit underneath the operations umbrella of our company. So my focus is fleet operations, business intelligence, and obviously the construction technology portion. And when I refer to construction technology, I'm referring to our grade control group, our survey group, all the automation that happens out in the field on the equipment. So a little background on myself. My career started out as an operator. So I was a heavy equipment operator and turned into field supervision to right into the survey group to where I am now under the operations umbrella. So I've kind of worked up from the boots on the ground and seen it kind of from all facets. My one shameless plug will be you can follow along on our technology adventures at technology_sandbox. It's been a great platform to learn about construction technology and how it relates to real world applications. There's been some great conversations on there, and it's brought a lot of awareness and a lot of learning to the industry of the people on that platform, and that's on Instagram. So a little bit about the company. Veit Company is a 95-year-old company based out of the upper Midwest or Minnesota. We have divisions in earthwork, utilities, demolition, foundation, dredging and diving, and CIPP. And then we also operate 2 C&D landfills, construction and debris landfills, that serve 4,000 roll-off boxes. So we kind of have our fingers in a little bit of everything. Half of the revenue of the company comes from earthwork projects. So last year we had, in the year of 2021, we had about 160 earthwork projects throughout our company. 120 of them were using tech. When we talk about construction technology, when it comes to Veit, we can kind of break it down into 3 areas. So the first one being project control and management. So that's going to be all of our time cards, digital progress tracking. Foreman's entering a lot of that data and then tracking the projects via the cost codes and compared to the bid. We get into fleet management, telematics, all the smart data off of those machines, and then obviously where we're at today of grade control. So that's one we'll focus on today for us. So I just want to kind of talk about our logistic overview and just kind of what we're up against. So like I said, we've got 160 earthwork projects across the company. We've got offices in Minneapolis, Minnesota, Milwaukee, Wisconsin, and then also Duluth, Minnesota, which is 2 hours north. So we serve that 5-state upper Midwest area. We're starting to branch out quite a bit too, and chasing clients outside of that region and getting down into the entire United States. So we're being forced to serve those crews as well as they perform some of those projects. Our projects vary from $50,000 up to $20 million. And they can range from being on site 1 week steady to 3 months in and out every other day, to 2 years of steady crews on the job. So it varies drastically in terms of what we're serving and what our projects are looking like. But what that all comes down to is we are moving a lot of equipment and a lot of people at the same time. So when I talk about the projects, when we have 120 projects that we're serving, we typically set up a civil model, and then we're also setting up an architectural. So the civil is representing a vertical datum of the civil elevation. So in our region, it's 900 to 1,000 feet above sea level. And then the architectural drawings or the architectural projects are representing that 100 elevation for footings and the architectural and structural drawing. So within those, each one of those projects, we're setting up 1 to 3 models each. So on the civil, we're finished grade, subgrade, utilities, some of those things. And then on the structural side of things, we're setting up top of footing, bottom of footing, and some finished floor things. So we're creating, for each project that we get, we're creating 2 to 6 models, say on average across all the jobs that we're doing. So it takes a lot to get that data created and then out to the machines as well. So like I said, we serve that upper Midwest. We manage about 100 grade control assets, and you can kind of put a 50% spread on that. So 50% of them are going towards your excavators, dozers, your on machine systems, and we use Trimble grade control for those systems. And then you take the other 50% and put it in the rovers. So we're using the Trimble SiteWorks platform for a lot of those things too. So To manage all of this work, we've got 4 dedicated team members that do that, 3 out of the Minneapolis office, and then 1 out of the Milwaukee office as well. And for the most part, all of them are creating models. They're supporting on-machine diagnostics and support, and then also training in real-world applications. So when I think about a digital contractor, successful one, they've embraced the technology, they've identified those tools that make them successful and give them that ROI. They've looked at that investment, not what it costs them, but what it makes them. So when they implement, it's from the top and it goes all the way down to the end user. So there's buy-in and there's confidence throughout the entire investment process and implementation process. I think one of the biggest pieces of a successful digital contractor is they put somebody in charge of it. It's a champion that will drive that innovation after the initial implementation. It drives the progress and supports and maintains those platforms, and it drives confidence so that when we're creating these units, that we can leverage the features and availability that they have to us. So you get in what you get out what you put in. You got to water that along the way for it to grow. So how does that apply to Veit? So when I talk about our footprint, I talk about our logistics. Our machines and our 3D technology is basically worthless without that model, if you will, the data. So getting that data to the field is extremely important. And how can we increase that speed to get it out there so that we can keep our field crews successful? So we adopted the Trimble workflow, TCC at the time, but we've had it for about 6-7 years now. So we use Trimble Works Manager at this point. So when I talk about a connected workflow and I talk about the cloud-based data, we're using Trimble Business Center and publishing that data up to Works Manager. From that point, we're able to pull all of that data down to the project sites for whatever units or assets are on that site, whether it be a rover, grader, excavator. So that could be the project startup, the initial project startup, but that also can be all the addendums and changes throughout that project so that we are always grading on the latest and greatest designs. Connectivity is key for that, right? So our projects are moving around so much, so we can't set up wireless mesh networks or anything else on the projects, and the footprint changes quite a bit where it's not cost inducive. So we've connected every single one of our assets to the internet. So we've got modems and data plans on that, and we manage that flow. So with that process, we've got all of our projects are using data transfer. We're doing all of our remote troubleshooting. We're doing all of our diagnostics, and we wouldn't be able to do that with 4 people. We'd have to increase our team by at least 1 or 2 people if we wanted to go back to that old way of transferring data via a USB stick, whether it be email and then talking that person through, that end user through that. Our guys are really good at moving dirt. They're not tech savvy. That's why we have jobs. So to be able to bridge that gap, instead of having to talk that person through, get that data onto that USB stick, walk out to that machine and plug it in for the latest and greatest, if they have time. Now eliminating that and just calling the operator or sending out an email saying, or getting a notification on the machine saying, project has been updated. Do you want to upgrade or update the design? So it's streamlined that data flow immensely. So let's talk about what that means. So like the old process of emailing that data out or driving out to the job site. So 30 minutes from the job site, it's a nice little drive. It's a beautiful day out, but it costs us money, right? So what can I do with that time that we have? And so you think about it, it's kind of an intangible because it's just what we did at the time. But inevitably you get out to the site, you got your 30-minute drive, and now you haven't seen that foreman for a while. So you catch up with him, the machine's unavailable, so you can't upload the data or whatever the unforeseen may be. You end up inevitably spending 2 hours away from the office. And what could you do with that 2 hours? Could you be building a model? Could you be managing the hardware, the software, version updates? What else could you be doing with that time? If you're project management, could you be bidding another job? So those are the questions you got to ask yourself. But using the Works Manager workflow, we're saving, just on a 30-minute drive, 60% of time, basically. And then you can equate those to your dollars, internal dollars. Same thing. The further you get away, the more the saving. 1 hour, you're out of the office for 3 hours. Whether it's you send it to a Gen Soup, now that Gen Soup's got to drive there. So there's intangible hours there that we're spending and dollars that we could be associated with something else. So support calls, like what does support calls cost us? Have you actually tallied it up? It's such an intangible cost, right? And it's probably not something you're going to see on a P&L when you're like, you're going to see the cost of the system. I spent this X amount on my subscription and my data plans. That's a cost you're going to see. but how do you quantify that support call? So we figured on an average, it costs us about $200,000 a year before Works Manager. So you take an hour-long phone call. So what we did is we averaged out an hour-long phone call because you've throughout an entire month, and we've averaged that over 10 months. And so then now we have to talk that operator through. So call me, there's something wrong with it, go on this screen, this screen, this screen. So what's included in that cost? We've got an operator, they've got their time. We've got a support person, we've got their time. We've got a machine that is actually down, being unproductive, so we've got that time. So that time, that 1 hour equates, it adds up very, very fast. So now with Works Manager, being able to remote in and see what's going on, see all the diagnostics, we can look at the diagnostics and we can say that we have a data there that is the diagnostics saying, oh, it's a base station. Now we can do a very, very direct approach to it. Say, go check your base station, or get out and change your coil cables, or whatever it may be. If I can't see it, then I can always go back to go back to work, and let me figure it out a little bit before. Let me figure it out while you go back to work. And so now that machine, I've taken that machine out of it, and I've also taken out the operator's time while I figure it out. So that's saved us a tremendous amount of money. When we get into training, we can do training in the wintertime, but they're not going to hold on to that training. So how do we apply that training and apply that feature in a real world scenarios? Now that we've given them that awareness, now they call us up and they say, hey, I remember that thing that you talked about. How can I apply it in this situation? I think I've got a situation, but I don't remember how to do it. We can now log into that machine and we can talk that operator through in a real world application of how to use that feature and leverage it. So that's helping us be able to leverage the systems so much better and get the features out of it and give the confidence to the guys in it as well. So now with the evolution of machine mapping, we've already got the infrastructure in place. We just physically have to turn it on. So we turn on the system. We've got all of our connectivity. We're getting real-time production data off of our machines. It can paint a story. We can pull off machine mapping data for as-builts. We can pull machine mapping data off. And then for soil corrections that we may or may not have gotten. So it's always giving us kind of that backup plan, but it also gives us a proactive environment to plan our work and see what the productions are doing compared to load counts, for instance. To see if we're going to meet the schedule, that we're meeting or beating our production goals, so that we can adjust our schedule and communication back to the owner, giving them just a real-time feel of where the project is and making it a partnership as well. So grade control is obviously too. We can talk to the OEMs. Oh, that saves us 30%. It saves us 40%. And how do you do that without a base model of this machine is doing it without grade control and this machine is doing it with grade control, and it's just such a controlled environment. But as a lot of you know, that in an earthwork environment, there's so many variables that it's hard to quantify that. So I just want to share just a success story that we had specifically related to grade control. So we had a project here that was a 700,000 square foot distribution center. So the overview of it is we had 380 column pads that we had to dig. So we bid that project with two excavators, two 336s or 36-ton excavators to keep up with the schedule. And with that, we had basically two operators, two excavators, and we also had two layout guys basically laying everything out. To make matters a little bit more challenging, they asked us to neat dig all the column pads. And for those that you don't know what neat digging is, basically you take the formwork out. The picture doesn't represent neat digging. But a neat dug column pad is you take an 11 by 11 pad and you dig an 11 by 11 hole. So our tolerance horizontally is now much greater versus oversized on a traditional formwork. What it does is it speeds the schedule up significantly on the concrete side of things, but it also makes our work much more finicky and it slows us down to an extent. So with that, we implemented our first automatic excavator in that scenario. So with that implementation, we were actually able to meet and beat the schedule for the column pad pours with the concrete crew with one excavator. So we completed the entire thing with one excavator. We eliminated the two people on the ground using 3D grade control, and obviously the person in the cab. So we eliminated one machine and 3 people, and we still met or beat the schedule. And to make matters just like one step up is we never had to go back on one column pad because we were always within tolerance, vertically and horizontally on those column pads. We were bound to that horizontal tolerance because obviously the subcontractor did not want to put on any other extra mud or concrete, so that we were bound by those horizontal tolerances as well. So they were happy all the way through. And the last example here too is 700,000 square feet. We had to grade all that entire floor. So we implemented motor grader and UTS on that project. Over that 700,000 square feet, the subcontractor went over 11 yards of concrete. And that's including all of the washouts. That's everything that they went over according to their quantity and the amount of material that they bought. They went over 11 yards. So we asked them what grade they wanted to be at. They told us, and we put it to that grade. And it got to the point where typical would be they go out and grade it, or we go out and grade it. Concrete sub comes behind us and they grade it out with their skiddy grader and they put the fine tune on it. The skiddy grader was getting to the point where he was just rolling around rocks, and he asked us to leave just a little bit so that he had something to do and prove that he could do it. So moving forward, we now know that we can eliminate that. We can eliminate the costs and subcontractor side of things, and which in tune correlates over to the GC as well, because it doesn't cost us anymore to put in a 1/2 inch high, a 1/4 inch high, or right on grade, because we have grade control. So if we can put it on wherever they want it, it's going to speed up the project immensely. And then obviously then we get more work out of it too, because they enjoy working with us because everything's right. So those are just a couple of the wins that we've had over the years, and just how it correlates to us and our bottom dollar. So that's all I got for now, Alex. I appreciate the time.
Okay, well, thank you very much indeed, Britton, for giving us those very concrete examples of what you've been doing. Just time for 3 quick questions which have come in. How long have you been using grade control on your machines, and what difference has it made in terms of your productivity?
We've been using, 15 years at Veit here. So the amount of work we can do has increased significantly. So I would say that 30 to 40%, you're eliminating people, laying out the stakes, the project schedule. We can get things done so much faster.
Okay, another question. Could it be an issue having so much data available? How do you ensure it's all used correctly?
We filter it through our team. So there are variables with, say, machine mapping data. We communicate with the project teams as well. And then within Trimble Works Manager, there are versioning updates. So we know exactly which one we're supposed to be on, as well as dates last revised. So there's a huge communication process with the project team so that we can make sure that they are up to date on the latest one.
Okay, are you seeing more and more contractors adopt technology? Is industry adoption increasing?
I would say over the last 2 years, industry adoption has increased significantly. I would say, your larger contractors, I guess like us, they have had a huge journey in it. They've been in it for 10, 15 years. I would say where the biggest adoption curve is going to be in the smaller contractors, the 2 to 3 machines that are being used, and they're starting to see the advantages of having the technology out there.
Okay, and a final question. What kind of hardware is used to determine the position of the machines? Do you use RTK technology?
Yeah, so we use Trimble grade control, which in turn is RTK technology running a base station, and then a calibrated model or calibrated project.
Okay, well, thank you very much indeed, once again, for being with us from, you're in Minnesota, I think, right?
Yep.
Okay.
Starting to warm up. So.
Thank you.